Good morning, good afternoon, good evening, wherever you may be in the world. Welcome to my channel. Welcome to this particular segment that is about the examination preparation series that has been going on for a while now. And we are in question 8, A4, and A5. As you can see on the board here, I've got the keywords and the equations that are needed to answer the questions. All right. So let us take a look at the first question that we are going to interact with. Have a look. Great. So the question is, we need to find the values of x in this equation right here such that this values of x, which will be written in terms of k, will lead to the equation having real roots. And what do we know about real roots? Discriminant must be greater or equal to 0. Okay. What do we need to find the discriminant? The quadratic equation must be written in standard format. Is it in standard format? No. We don't have a 0 here, we have a variable. So we need to expand, transpose, and write it in standard format. So let us expand this binomial. When I have 4x squared minus 4x plus 1. Transpose to k becomes a minus k equal to 0. Okay, so if we look at it, we have 4x squared minus 4x, and I would like you to see this as the constant. Okay, in our general way of writing the quadratic formula, okay, that is it, and that is what I want you to see, that 1 minus k represents the constant in this expression. Okay, good stuff. Are we ready to find the discriminant? Yes. So for real roots, we know that discriminant must be greater or equal to 0. What is the discriminant? It's b squared minus 4ac. Good. So what is our b value here? Negative 4. We're going to square that. Minus 4 times what? A, it's 4, and c, it's 1 minus k. So we have 16. Then when I have a negative 16 there, we distribute, it's going to be a negative 16. Negative 16 we distribute, then we have a 16k. So the discriminant is actually 16k. Alright, so now we are asked to find the values of x in terms of k. So we are not done yet. We know that the quadratic formula is like this: square root of the discriminant over 2a. So this guy comes in there, okay, and the negative b will be negative of negative 4, double negative, so it's 4 plus or minus square root of 16k over 2 times 4, which is 8. Okay, so the values of x in terms of k can be written like this, or you can simplify and find the square root of 16, which is a perfect square, and that will give you a 4, right? 4 plus or minus 4 root k all over 8, and you can simplify there to have a 1 plus square root of k plus or minus square root of k over what? 2, and k must be greater or equal to 0. That is the restriction there, because we want real roots. So this takes care of question A4. You could have done this step within the equation, doesn't matter. Okay, there's no need to separate them, but I just, saw, a need to do so in this instance, because it leads us then to A5. What does it look like? Take a look. Okay, so what is the question in A5? We are asked to find the 3 values of k, which is a constant in this equation, such that the roots of this quadratic equation will be real, rational, and unequal. Okay, so what is the keyword here? You want rational roots. Okay, there's a condition that applies to that. It means your discriminant must be greater or equal to 0, and okay, it must be a perfect square. Okay, giving you rational and unequal roots, because remember there's a plus and a minus sign, just like we had in the previous question. Okay, you want to find the same number definitely, unless that was equal roots. So are we ready to find it? Look at it. It's slightly different from this one because we're going to have this type of expression now, or equation. Minus 4x plus 1 plus k. Here we had a 1 minus k, now we have a 1 plus k, which then represents our constant. Okay, so what is our discriminant here? We have a negative 4 squared minus 4 times 4, okay, and the c value is 1 plus k. So this is 16 minus 16, and we distribute there, minus 16k. Discriminant is negative 16k. We go back to the question. How many values do we need for this k? 3 values, such that this discriminant will be greater than 0 or greater or equal to 0, and also a perfect square. But if we observe the expression here, negative 16k, 16 is already a perfect square. So we don't want to jinx that, we need to leave it there. So what must k be for this to be equal to a positive 16? K must be negative 1. So therefore, one value of k that we know is definitely that one, negative 1. Okay, if you put it in there, the discriminant will be a 16. What will it be? A perfect square. Okay, what else can you think of? Okay, 16, negative 16 times what? Times 2 gives you a negative 32, or times negative 2 is positive 32. It's not a perfect square. What about this one? K equal to negative 1 over 4. What will that give you if you substitute that for k? It will give you a positive 4. Okay, discriminant will be a positive 4. Is 4 a perfect square? Yes. So that is our second value of k. Great stuff. The next value of k, or the last value of k, we need one more. What will it be? K will be equal to, okay, a negative what? Definitely it must be a negative number, because we need to produce a double negative to end up with a positive number. Negative 1 over, here is 16. Good, because that will give us a perfect square as well. Square root of 1 is 1. So those are the values of k that solves this problem. Okay, very interesting combination here of the two. You can just check the similarities and the differences. Okay, it's very important to read the question very carefully. So here we're not asked to find the values of k, but write x in terms of k. But here we had to produce numerical values of k. All right. So this takes care of A4 and A5. We are going to complete question 8 with the last question that is under question 8, which is B. All right, so take a look. Right, so in this question, again, we're dealing with nature of roots, and we are not far off from where we were previously, okay, or in the previous questions. So here we're given two equations, and we're told that the larger root in this equation is p, the larger root in that equation is q. Okay, keyword there is larger root. We understand that the quadratic formula has two solutions generally, plus and a minus is there to indicate that for us. Okay, the fact that we have a larger root here, it means we're going to take the positive sign, because the negative b here will be actually a negative number, just in terms of the variables that we see here. So what are we going to do? We're going to find the roots here and pick the one with the positive sign and find the roots, then pick the one with the positive sign. Okay, so we have x equal to negative what? Q plus or minus square root of q squared minus 4 times p times r over 2p. What are the roots there? X equal to negative q plus or minus square root of q squared minus 4 times a is 1 and c is pr over 2 times 1 is just 2. Okay, so what does that mean in terms of what we're given? Larger root here, it's p, so the p value here will be negative q plus, right? Because if we subtract, definitely going to have a smaller root. Negative q minus something else will give you a more negative answer. Okay, so it's a plus square root of q squared minus 4pr, okay, over 2p, and here q will be equal to negative q plus square root of q squared minus 4pr over what? 2. Okay, so that's what we have. And the question is now find the ratio. What is p is to q? Okay, so we substitute negative q plus square root of q squared minus 4pr all over 2p is to what? Negative q plus q squared, okay, minus 4pr over what? 2. Okay, fraction divided by another fraction, you tip this one and you multiply, you see that there will be cancellation of this, okay, cancellation of the 2's because it will become a numerator there, and you actually end up with 1 over p is to 1. Okay, this was a straightforward question. You just needed to apply your mind in terms of the meaning of a larger root and do what you have been doing, that is using the quadratic formula. Okay, thank you guys for tuning in. We are now heading off to question 9 and 10. Those will be the last 2 videos for paper 1 examination preparation, and thereafter, of course, we will engage with some paper 2 content as well. So I hope this was beneficial and helpful to you. Wishing you well for your examinations. See you on the other side. Sharp, sharp.